continuation of semiconductor, that rectifier. See, the rectifier, which is nothing but the process of converting an alternating current into a direct current, which is called the rectification. The device which we are using for that process, which we can call it as a rectifier. So what is the principle of rectifier? Which when a PN junction diode is forward biased, it offers a low resistance, and when it is reverse biased, it has a high resistance, as we know that. That time it conducts current well only in one direction. This unidirectional property of the diode, which helps to be used as a rectifier. When AC signal is fed to a diode, the diode is forward biased during the positive half cycle and the current flow through it. During the negative half cycle, the diode is reverse biased and does not conduct current. Right. So that signal gets rectified. We'll see the junction diode has half wave rectifier and we can use it as a full wave rectifier. One by one we can see the junction diode as a half wave rectifier. The primary coil of the transformer is connected to the AC mains and the secondary coil is connected in series with the junction diode, and load RL which is also is connected. Suppose an AC supply is supplied to the primary circuit. What will happen to the secondary of the transformer which supplied desired alternating voltage across A to B, and during the positive half cycle of AC, the ends A is positive and the end B is negative. The diode D is forward biased. At that time the current I flows through RL. As the input voltage increases or decreases, the current I also increase or decrease, and so does the output voltage across the load, right, R. The output voltage across RL is of same waveform as the positive half wave of the input. What you are seeing on the graph, through the graph we can get it. During the negative half cycle, the end A which is become negative and B is positive. A is negative, B is positive. Now the diode is reverse biased and no current which flows. No voltage appears across RL. So only half wave is rectified. So this process continuously is going on, the process. That we can call it as a half wave rectification, and this rectifier is a half wave rectifier. Right. Got it? Yes, these are all the points which I explained, I have given for your notes. The next one is the junction diode as a full wave rectifier. Now, the input AC signal which is fed into the primary coil of the transformer, the two ends A and B which is there, that is secondary is connected to P, and the diode D1 and D2. The secondary is tapped and the center tapped one, right, that is load RL. How it is working we can see. The voltage at we have given end A, that is input D1 we are giving, and end B D2 of the secondary with respect to the center tap. That will give the out of the phase each other. Now, during the positive cycle, an input, the end A is positive and the end B is negative with respect to center tap. What will happen that time? The diode D1 get forward biased and conduct current. And along the path of, see the circuit, AD1 XY TA. As this will indicates the D2 that time is get reversed and does not conduct current, right? And during at the time of negative half cycle, that time end A becomes negative and B becomes positive. Here at that time the D1 get reverse bias, does not conduct current. the D2 will conduct current. How? The path we can take B D2 XY TB. See, B D2 XY TB. Right. And so by that way, the load is getting obtained for both half cycles of input AC. Right. This process we can call it as a full wave rectification, and this arrangement is full wave rectifier. Right. Now, what is Zener diode? This is the symbol, circuit symbol for the Zener diode. A junction diode which is specially designed to operate only in the reverse breakdown region. And it is continuously not getting any damage. Without any damage, it will be get continuous breakdown region, that we can call it as Zener diode. The IV characteristics of the Zener diode we can see through the graph VI characteristic. See the characteristics of the junction diode when we are applying the reverse voltage, that is getting reduces to the breakdown voltage of the Zener. The current suddenly will get increase. So thus after the breakdown voltage, a large change in the current can be produced by almost insignificant change in the reverse bias voltage. In other words, we can say that the Zener voltage remains constant, and even though the current through the Zener diode varies over a wide range, this property of the Zener diode is used for regulating the supply voltage. Voltage regulator and all it is using. Right. Thank you, children.